Hello friends, welcome to engineering tutorial. So far we have covered about the standard Boolean expressions or the Boolean expressions in canonical form, which is SOP and POS. Okay, so but what do these SOP and POS, what do they mean? Okay, what do they signify? So we have to understand that. Okay, what is the significance of the SOP and POS expression, Boolean expression? So we will try to understand that in the next set of videos. Okay, suppose we first let us consider the SOP. Okay, we have a Boolean expression of, first let us consider a two variable expression. The available variables to us are a and b. Let us say we have a Boolean expression given as a bar b bar plus a bar b. So it can be represented in this way, in the min terms form. I have already discussed about this. So in SOP we know that every complemented variable, it represents logic 0, and every uncomplemented variable it represents logic 1. So a bar b bar actually represents 0 0 in binary, and it is decimal equivalent is also 0. Similarly, a bar b, it represents 0 1. A is complemented, that's why it's 0, b is uncomplemented, so it is 1. Here both are complemented, that's why 0 0 in binary, and here it is in decimal, it is 1. So here it is 0 and 1. So this is the SOP expression. So what does it actually mean? Okay, now let us form a truth table of two variables and the output as f. Okay, so two variables a b and the output f, the Boolean expression. The variable combinations, the input combinations are 0 0 0 1 1 0 1 1. Now let us put the values of a and b, the respective values in input combinations, in the output expression. Okay, first a and b are 0, so f will be, we are putting in there 0 bar plus 0 bar into 0, so it will be 1 into 1 plus 1 into 0. Complement of 0 is 1, so it is 1 plus 0, which is equal to 1. Here it is Boolean addition, so f is equal to 1 in this case for the input combination 0 0. See, 0 is present here, 0 0 is present in the min term expression. Okay, now let us put 0 and 1, the second input combination. This is for 0 0. Okay, binary and decimal. Okay, now let us put 0 and 1, 0 and 1, this will be 1. Okay, so this will again change, 0 A is 0, this will remain a 0 bar, this will become 1 bar. Okay, again this will be 0 bar and this will become 1. So this becomes 1 into 1 and here it becomes 0. So again it is 0 plus 1 and it is 1. Okay, f is again 1. The output Boolean expression is again 1 for the second input combination, that is A is 0, B is 1, which is also present in the min terms expression 0 and 1. Okay, so we have evaluated that for input combinations A and B both 0 and for A is equal to 0, B 1, the output expression, this Boolean expression is 1, logic 1. Now let us put the third input combination, which is 1 0. One and 0. Okay, A is 1, B is 0. In binary it is this, and in decimal it is 2. Okay, let us put the value. So A is 1, B is 0, so it will be 1 complement into 0 complement plus, or it is the OR. When I say plus, it means it is OR, and when I say product or multiplication, it means AND. Okay, so A complement again, it is 1 complement into 0. Now the result, 1 complement is 0, 0 complement is 1, it is 0 into 0. So it is 0 plus 0, which is equal to 0. So in this case, the value of the Boolean expression is 0. Now see, this input combination 1 0 or the decimal value 2 is not present in the min term. It is not present here. The Boolean expression is 0. Similarly, the last input combination, that is both A and B are 1. We'll put the decimal value, that is 3. The input combination is A is 1, B is 1, which can be represented by the binary 1 1 and the decimal 3. Okay, so let us put it. A complement, B complement, 1 complement into 1 complement plus 1 complement 1, that is B. So it is 0 into 0 plus 0 1, which is 0 plus 0 again, which is 0. Again, for input combination A is 1 and B is 1, the Boolean expression value is 0. So again, you notice that in the min terms, this 1 1 or the decimal value 3, the decimal equivalent, is not present. So from this, what can we conclude? We see that there is a pattern emerging here. Okay, now for all of those input combinations, okay, that are present in this min term, that is 0, which represents 0 0 binary, and this is the decimal value. What does it mean? It means the input combination A is equal to 0, B equals to 0. Similarly, the min term 1, it is the decimal. Okay, the binary is 0 1. What does it represent? It represents A is equal to 0, B is equal to 1. Okay, similarly, for 2 1 0, it represents A is 1, B is 0. For 1 1, that is 3, A is 1, B is 1. That's what it represents. So we see that for the SOP expression or the sum of min terms expression, it is applicable at those points or those input combinations where the value of the Boolean expression, okay, the value of the Boolean expression given by the SOP or sum of products form is 1. Okay, so we can say that the Boolean expression given in SOP is applicable for those input combinations where it is equal to 1, logic high. Okay, FSOP is equal to 1. It means when we represent the SOP in this form, either in the Boolean terms, in terms of Boolean terms, or the min terms in this form, it means at these input combinations A bar B bar, it means A is 0, B is 0, and A bar B, that is A is 0, B is 1. At these input combinations, the value of this expression will be 1. See here, A bar B bar, it means A is 0, B is 0. You can see complemented variables are represented by logic 0 and uncomplemented are represented by logic 1. I have already discussed these things in detail in the SOP basic concepts. You can please check out that video. And similarly at A bar B, that is A is 0, B is 1, which means at 0 1, A is 0, B is 1, the Boolean expression is 1, and at all those other input combinations, that is A is 1, B is 0, A is 1, B is 1, which are not present in this min term list, in this bracket, at those the value of the Boolean expression will be 0 or logic low. So this is what the SOP, the sum of product, it means. This is what it signifies. This is the significance of the sum of products expression. It specifies those input combinations at which the value of the Boolean expression is logic 1, logic high. Okay, these two input combinations are represented in this min term expression given by this Boolean SOP expression. 0 0, that is 0, 0 1, which is 1, and at those points the value of the Boolean expression is 1. Okay, now it is applicable for all the Boolean expressions. Here for simplicity I have taken a 2 variable Boolean expression. It is also applicable for 3 variable expression, for 4 variable expression, for 5 variable expression. As many number of variables you pick, this will be applicable. But here, if I would have taken more variable, it would have been lengthy and the space would have been sufficient to cover up that. So that's why for simple analysis I took a 2 variable expression. Okay, so you can check out whether this thing is applicable for 3 variable expression. Take 3 variables A, B, C, write the simple SOP expression, list it in terms of this min terms, summation of small m, whatever the min terms are present using this rule. Complemented variables are 0, uncomplemented variables are 1, and then draw the truth table. Check whether at the given input combinations given by this min terms, specified by this min terms, whether the output is coming 1 or not. So that is a homework for you. Okay, you try it out. Okay, then go for 4 variables if you want. Okay, you will find the same results. Okay, so next we'll discuss about the POS significance in a separate video. Okay, I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to electrical, electronics, instrumentation and communication engineering. And if you like this video, please hit the like button, and thank you very much.